Hello everyone, I am Shalaka Deshpande. Welcome to my YouTube channel. Our today's topic is interrupt system of 8051. Okay, so before directly starting this, I want to tell you one concept about the ports. Okay, so that you will get a general idea about the ports. Okay, you can actually imagine how the scenario is there when interrupt system is enabled. Okay, so the port, suppose there is one microcontroller and it is having a port A. Okay, and assume that port A is configured as an input port. So what microcontroller does is continuously checks the status of a port A that is falling, and if the byte is not available at port A, it sends a byte to port A. Okay, and when the byte is available at a port A sends that byte to external device which is connected to that microcontroller. Okay, this is the scene when port A is set as an input. Okay, now we will see the if port is set as an output port. Suppose there is a microcontroller, it is having a port B and port B is set as a output. It is configured as an output port. Okay, so it again continuously checks the status of a port B. Okay, and if port B data is available at a port B at output buffer, it sends that data to external device, and when port B, which is configured as output port, sends a data to external device, the output buffer becomes empty, and again microcontroller continuously checks the status of a port B, and when port B is empty, it sends the byte to port B. Microcontroller sends the byte to port B and port B again sends it to external device. Okay, so whenever the port B when set as when configured as output port, microcontroller continuously checks its status, and when the output buffer is empty, it continuously sends byte to the output port. Okay, fine, and output port sends that byte to external device. So these were the read and write operations. Okay, now we will start with the topic interrupt system of 8051. Now in 8051 it supports 5 interrupts. Okay, 2 external interrupts, 2 timer interrupt and 1 serial interrupt. Now what is serial interrupt? Serial interrupt enables a serial communication between external device and the microcontroller. Okay, and this serial interrupt is OR logic or combination of transmit interrupt and receive interrupt. Means transmit interrupt is denoted by TI and receive interrupt is denoted by RI, and their odd combination is serial interrupt. Okay, now can you see this diagram? IE7, IE6, 5, 4, 3, 2, 1, 2, 0. Now these are the details of interrupt enable register in 8051, and interrupt enable register is a special function register. Okay, so let's see what are the bits inside the interrupt enable register. Okay, EA, RSD, RSD, then fourth bit is ES, third bit is ET1, second bit is EX1, ET0, and zeroth bit is EX0. So these are the bits of the interrupt enable register. Okay, now we will study these bits in detail and what are their functionalities. See, the interrupt can be enabled or disabled by setting or clearing the bits of interrupt enable register which I have drawn. Okay, so this interrupt enable plays a very important part in enabling or disabling the interrupts, okay, which will be received by microcontroller. Clear? Fine. Now let's see details. EA is enable all the interrupts or disable all the interrupts. Then RSD is reserved for future use. ES enables serial interrupt. As I already told you, serial communication between external device and microcontroller is enabled if this serial interrupt is enabled. Okay, then ET1 enable timer 1. There are 2 timers, timer 1 and timer 2. To enable timer 1 we have ET1. Okay, and EX1 enable external 1. External interrupt means when memory is connected to microcontroller or a microprocessor, it can send interrupt only if enable external 1 or enable external 0 are enabled. Okay. Now ET0 is enable timer 0. So what we have seen, EA is enable all, RSD is reserved, ES is enable serial, ET1 is enable timer, EX1 is enable external 1, ET0 is enable timer 0 and EX0 is enable external 1. Now how do we enable and disable it? How do we enable and disable the bits? See, if any of the bit is 1, then it is enabled. If any of the bit is 0, then it is disabled. Okay. So, if any of these bits which correspond to the interrupts, if they are set to 1, then that particular interrupt is enabled. And if any of these bits are 0, then the corresponding interrupt will be disabled. Okay. Now, the importance of EA. This EA has to be 1 in order to enable all the interrupts. EA enable all has to be 1. Okay, for example, if enable all is 1 and ET1 is 1, then the timer 1 will be enabled, timer 1 interrupt will be enabled. If enable all is 0 and ET1 is 1, even if the ET1 is 1, it is disabled. Why? Because this enable all is 0. In order to enable the interrupts, enable all has to be 1. For example, if these bits are all the bits are 1, they won't be serviced if enable all is 0. So to service the interrupt, enable all has to be 1 compulsorily. Otherwise, it will disable all the interrupts. Okay. Now, next is one example. Enable timer 0 and disable all others. We have to enable this timer 0 and disable all others. Now, there must be a question before you. How do we set or clear the bits of interrupt enable register? So, answer is this code. ORL IE comma hash 1 5 times 0 1 0 B. B is because it's a binary data. Okay. So, interrupt enable register. This immediate data. This is stored in interrupt enable register. Okay. Means how it is stored? Contents of interrupt enable are ORed with this immediate data. ORL is OR, logical OR. So IE bits are logical ORed with this immediate data, and whatever is the result, it is stored in IE register. And we have assumed that initially IE register all bits are 0. Okay. Now what will happen after OR operation? EA and ET0 bits will be set. Means EA will be 1 and ET0 will be 1. So timer 0 is enabled, but we don't want other interrupts to enable. We want to disable all other interrupts. There are other interrupts and we want to disable it. For that we have AND operation, ANL IE comma hash 1110010B. This will disable all the interrupts. How? By resetting enable serial, enable timer 1, enable external 0 and enable external 1. Means these all except timer 0, all the bits are disabled by logical ANDing the contents of IE with this immediate data. Okay. So in this way we can set or clear the bits of interrupt enable register by using the instruction ORL and ANL. Okay. So this was about the interrupt enable register in 8051. I hope you have liked the video. Please like, share and subscribe my channel. If you have any doubt, you can ask me in the comment section below. So bye bye and thank you for watching.